Okay, so now let's switch to R. First, as I showed you last time, we start by loading the LSAfun package. Then we need to load our vision space. I'm first navigating to the directory in which I saved it. So as you can see here, this directory contains proimage.rda. That's nice. I want to load that using the load command. Going to take a few seconds because it's rather large, 500 megabytes again. I can check the dimensionality of this object. So you can see here that it contains 170,000 entries, each with 400 dimensions. And you can check how these entries look like by checking row names. So for example, Bumblebee Pro. In our annotation scheme, Pro always refers to a prototypical representation. So this is your prototypical Bumblebee. If you need more information about the naming scheme, you can check the homepage where you downloaded it. And here you can see that the prototypical representations are always labeled name and then Pro. And here you can see how the individual images are labeled with numbers from 1 to 15 and with these codes. Okay, back to R. So using these things, you can use the LSAfun package in exactly the same way which I showed in the previous video. So you can compute the cosine similarity. Let's take Bull Pro because I read it here, and then Bunny. I have to specify the space in which to search, which is this one. And you can see that a bull and a bunny look quite similar. So this ranges between 0 and 1 again. And now let's compare the bull to, let's say, a bullet. And you can see that it's less similar. And for these computations, you can use all the functions that I showed in the LSAfun video. So similarities between lists of vectors, pairwise similarities between lists of vectors, neighborhoods, plots of neighborhoods. You can do everything that you can do for normal semantic spaces, also with the vision spaces. You can again check which entries are available in this vision space. So for example, you can check, is lion available here? And yes. And then you can also compute, for example, the similarity between some lion and some tiger. Here you can see that this particular lion, this first image of a lion, doesn't look very similar to this first image of a tiger. Obviously, in order for that to make sense, you would have to know how these images look like. But luckily for you, you have several ways of checking that. So first, if you check the homepage, you can see that these images have a specific path assigned to them. You can check all images which are available in the vision spaces by using a link that looks like this. So it's always storage googleapis.com homepage _images /images /name of the category /name of the individual image .jpg. So for example, when I copy that, let's use it here and search for lion 001, it's this image. And we can do the same for, let's say, tiger and tiger 001, which is this image. So this tells you that these two specific images that I just showed you have a similarity of 0.55 something. If you don't want to do this searching, you can also use a different option. That is, you can go to the ViSpa website. The address to that is vispa.fritzgünther.de. I'm going to insert the link to this website also in the description below. And here you can search, for example, lion in the picture picker. You will get these images of lions. And here you see this is our lion 001 again. So you have two different ways of checking which images you're actually working with. And of course, to finish that, you can also use LSAfun to compute the typicality of a given thing. So for example, you can find out that the typicality score of this particular lion is 0.8. And that, for example, the second picture of a lion is 0.9. So this tells you that this is a more prototypical lion than this. And of course, you're not restricted to stay within your category. So you can also say, how similar is this lion to a prototypical tiger? 0.68. Okay, that's it for now. I hope you enjoyed this video and see you next time. Bye.